two real scale samples which you receive in our scale lab. But what I want to say here, if you can focus for the first pictures and the second pictures, both of them are calcium carbonate. But what is the difference here? The first picture, this is kind of a scale, we call it calcite, and the second thing we call it organic. Here, they're just different in the structure of the crystals. Now we are discussing the problems caused by a scale. The first thing, emergency shutdown and direct financial losses by the failure in the downhole equipment where it needs to be replaced. Decrease in the production efficiency by plugging and limiting in the production oil and gas. Plugging the reservoir pore and significant reduction in the pressure. And finally, safety dangers. Safety dangers here, we talk about something called norm. Norm here is normally occurring reductive materials. Specifically, we talk here about the radium ions, radium 226 and radium 228 ions, which are very common to be associated with barium sulfide. Barium sulfide scale. Here we have the solubility. Let us start by the definition. The solubility is defined as the maximum amount of substance that will dissolve in the given amount of solvent at a specified temperature or a set of different physical conditions. Here in this table we have the factors that affect scale precipitation, deposition and crystal growth. Let us start by calcium carbonate here. Calcium carbonate, the solubility of calcium carbonate decrease with the increasing in the temperature and pH, and also its solubility increased by a partial pressure of CO2 and total pressure and total dissolved salt, which is TDS. Next, calcium sulfate, barium sulfate, strontium sulfate, the three of them behave like each other with the increasing of the pressure and total dissolved solid. When their solubility increase with the increase in the pressure and the TDS. For the temperature, we find calcium sulfate and strontium sulfate solubility decrease with the increasing of the temperature, whereas the barium sulfate solubility increased by the temperature. Finally, ion compounds. Ion compounds here, we can relate them by the existence of dissolved gases like oxygen and carbon dioxide and hydrogen sulfide. Here we have a case study. Recently, we received a sludge scale sample from one of the companies. When we received the sample, the first thing we do, as any scale sample we receive in the lab, the sample was extracted by using soft-slit equipment. In this picture, here we use toluene solvent to dissolve any carbon on the sample. The organic part here will soluble in the solvent, and the inorganic part will remain in the sample, which the most important thing we need. Organic part is sent to gas chromatography lab to be analyzed, and organic part is sent to be analyzed in XRD diffraction. The result we receive from XRD is help to choose the suitable solvent to save our time. Here you can see this is the sample after grouting and dry. Here we during the test each sample weighing 0.1 gram, and we prepared hydrochloric acid with different concentrations, 7, 10, and 15, and 20. The solution, 7% was put in the first test tube, and 10% in the second test tube, and so on. The reaction started immediately, and we could say gas bubbles were rising in the top of the solution. So calcium carbonate exists in the sample. Here, the result of XRD diffraction. As you can see, in the same sample, we have calcite with 53%, aragonite 23%, and varite 1%. Here, the test of the solubility. The first picture, the start of the reaction, and the second picture, the end of the reaction. And you can see the bubbles. Here, the solubility test we do at our lab. The first thing we try with the water. If there isn't any insoluble, means we have sulfite. Sulfite could be calcium sulfate, barium sulfate, or strontium sulfate. But if it is soluble totally, so we have sodium chloride. If we notice that there is a slow soluble or slightly soluble, we protect carbonate or sulfide. Here we need to use a different concentration of hydrochloric acid. If we notice that there is rising in CO2 bubbles, so it is carbonate. If we notice there is a bad smell, it is sulfide. Here we protect there is iron compounds in our sample. After we finish, if we find the sample calcium carbonate, we always recommend to use hydrochloric acid. For calcium, barium, strontium sulfide, we always advise to use chelating agent, which is that. For iron compounds, we protect to use hydrochloric acid plus chelating agent.
No,
Thank you.